Alright guys, so in this video we'll be reviewing partial differential equation. So we view the definition, the order of PDE, the degree of PDE. We have the linear and the non-linear PDE. I will start from the definition of a PDE. A partial differential equation, which is also known as PDE, is an equation that involves an unknown function and its partial derivative with respect to two or more independent variables. That is, we have an unknown function and the partial derivative of the unknown function with respect to two or more independent variables. So when we talk about partial derivative, it arises in different field. The application where you can apply PD in science and mathematics, you can apply it in physics, quantum physics to be precise, chemistry, you can apply it to chemical kinetics. So in fact, you can apply PD to some economics and some financial mathematics or even computer sciences. So these are some of the applications of partial differential equation. So we'll be reviewing the order, the degree, and linear and non-linear PDE. So for example 1, this is a good example of first order PDE. So it is also of degree 1 and it is also linear. When we say the order of a partial differential equation is defined as the order of the highest partial derivative. So it's defined as the highest partial derivative, and as you can see clearly, the highest partial derivative that we have in this example is 1. So the order is 1. Similarly, if we are to consider the degree of a partial differential equation is the degree of the highest order derivative, which occurs after the equation has been rationalized. So it is of degree 1 and it is of first order and first degree, and also it is linear. When we say when a partial derivative is said to be linear if the dependent variable and its partial derivative occur in first degree only. Now when we talk about the dependent variable is z and the independent variable is x and y. So when we say a partial derivative is linear, it simply means that the independent variable and its partial derivative has 1 degree, occur in the first degree only, and they are not multiplied together. So it simply means that this is a linear partial derivative. It is also of first order and it is also of first degree. So let's check some other example. So this is a third order partial PDE and it is non-linear according to the rules stated for a linear and non-linear PDE. So it is third order because the highest power in this case is 3. So it is all third order. And it is also of first degree because when we say that the order of a partial derivative of a partial PDE is defined as the order of the highest partial derivative occurring in the partial differential equation. So the highest partial derivative that occurs, you see we have the z, the x. So it is of third order and it is of what, degree 1. And of course this is clear that it is non-linear. So if it is linear, it simply means that the dependent variable and its partial derivative occur in the first degree. So because the dependent variable, which is z, did not occur in the first degree, do you understand? Did not occur in the first degree, so it simply means that this is a non-linear PDE. So we have another one. We have another example here. So this is first order, it is first degree, and it is non-linear. Of course it is non-linear because in fact we only have x. There is no dependent variable. We have just one independent variable. We have dependent variable z, but it is attached to a partial derivative. So it is non-linear. So it is first order and first degree. So similarly, with the same approach, you can clearly see that this is a first order first degree and it is linear. Why? Because it is linear. It is said to be, recall that I said the partial derivative is said to be linear if a dependent variable and its partial derivative occur in first degree. So if the dependent variable and its partial derivative occur in first degree. So the dependent variable that we have is z, so they occur in first degree. So of course this is a linear PDE. So this also, we have, this is third order, this is degree 1, and it is non-linear. So this is a third order differential equation. And lastly, you will be the one to determine the order of this. So this is second degree, degree 2, and it is also what, non-linear. So the order will be left as an assessment, so you can try and figure out what the order of this PDE will be. Thank you.